Let's take a look at this question. So the question reads, Sophia has 52 identical isosceles right-angled triangles. So an isosceles right-angled triangle, something like this maybe. Okay. She wants to make a square using some of them. How many different sized squares could she make? 6, 7, 8, 9, or 10? Okay, let's take a look. So the first thing we could do here is just sketch out the different options that she has, right? So the first way that you can make a square from an isosceles right angle triangle is simply by placing them next to each other like this. So this would be two of those triangles making one square. Now, I'm sort of making this into a table so that it's easy to follow. And we're going to call the number of options, we're going to call that right at the top. So option 1, option 2, option 3, option 4. Then I'm going to have a row that's going to account for the number of squares that's used. And then I'm going to add a row for the number of triangles that's used. Okay? So let's look at option number 1. So option 1 is simply taking two of those triangles, placing them over each other, and we're going to get one square. Now that's going to be our original square. And I'm going to highlight it with the blue box like this. Okay? And the number of triangles that's used is 2. Now the next option, option 2, so this is now the second different square that could be made. So if we take that original square and we place 3 of them around it, you'll get a new square. So in total, we have the second option, but it's using up 4 squares. So 4 squares, and the number of triangles now is going to be 8. Now, we can see a pattern emerging here, but let's just continue and it will get more clear. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the third different square. It's using 9 of my original squares, and in total it's using 18 triangles. And let's look at our pattern. So let's call the option number, let's call that n. Right? Then the number of squares is going to be n squared. Because if you look at it, 3 squared is 9, 2 squared is 4, 1 squared is 1. So n squared. Then the number of triangles is going to be multiplied by 2. So 2n squared. For instance, if you take 9 and you multiply by 2, you get 18. If you take 4, you multiply by 2, you get 8. So this is squaring, and that's multiplying by 2. So 2n squared. Now remember, that's the number of triangles, and the number of triangles cannot exceed 52. So 2n squared must be less than or equal to 52. Let's divide both sides by 2. So n squared is less than or equal to 26. Now square root. So n is going to be less than or equal to the square root of 26. N is therefore equal to 5, less than or equal to 5,099. But we can't have 5,099 options. That doesn't make sense. So we'll take the lower end of that range, so 5. So there's going to be 5 options using that original square. And this is what it would look like. Okay? So maximum 5 different options using this orientation of the triangles. But is this the only way? And the answer is no. If we take the same isosceles triangles and we take 4 of them and we arrange them, we can get one square. So this is now the different way that we can arrange these triangles. So let's call these options as well. Now you can see in this one, you have 1, 2, 3, 4. And now let this be my original square. So 4 isosceles triangles can make one square. Let's look at option 2. Now option 2, similar to the previous example, is where you take this original square and you place 3 exact same ones around it. So like this, like this, like this. And so again, we'll find a pattern emerging. Let's complete the rows. So square, there's one square here. In this case, there's 4 squares. In this one, there's 9 of my original squares. Now let's look at the triangles. There's 4 triangles here. In this one, there's 16 triangles. We can count it. 1, 2, 3, 4. And since there's 4 of them, 4 times 4 is 16. In this one, there's 9 squares, and each one has 4. So there's going to be 36 here. And so from here, we can get a new formula. And what's the formula going to be? So again, let the option be n. So the option is n. The number of squares, in this case, again, is going to be n squared. Because you can see again, you're going from 3 to 9, you're going from 2 to 4, you're going from 1 to 1, so it's n squared. But then the next bit is where you are multiplying that by 4. You multiply by 4. You multiply by 4. So the number of triangles is going to be 4n squared. Now the number of triangles, like we did before, cannot exceed 52. So 4n squared must be less than or equal to 52. Now n squared is going to be less than or equal to 52 divided by 4, which is 13. Then n, you square root it like we did before, is going to be less than or equal to 3, 6. Now we can't have 3, 6 options. So what do? Take the lower end. So from here, we're going to get 3 total options. And then from this previous one, you're going to get 5 total options. So 5 plus 3 is 8. So the answer to this question is you're going to get 8 different sized squares that Sophia could make. Thanks for watching. I'll see you in the next video. Bye-bye.